Welcome to myprojectbazaar.com. Project title: A study of sub-1 GHz frequency spectrum utilization in India. Let's see the abstract of our project. Generally, cognitive radios are designed in order to provide high reliable communication for all users of the network, wherever and whenever needed, and also to facilitate effective utilization of the radio spectrum. The issue of the spectrum utilization in wireless communication can be solved in a better way using cognitive radio technology. Because of fading or shading of the channel, there will be uncertainties in the received signal strength, which will lead to the wrong interpretation. To avoid this, we propose a spectrum sensing scheme for efficient data transmission for both the secondary and the primary users. For the spectrum sensing, we use centralized coordinator techniques. Here, in this technique, we have cognitive radio controller. The proposed spectrum sensing scheme for efficient data transmission for both the primary and the secondary users. For spectrum sensing, we use the centralized coordinator techniques. Here, this technique cognitive radio controller, when one cognitive radio detects the presence of the primary user, then it allocates the channel for that user. Finally, when the primary user is free, it allocates the available spectrum to the secondary users. This will improve the channel efficiency of the network. Now we are going to see the flow diagram. First, the network model is created. That is, the number of nodes are created in the network. The nodes are nothing but the primary and the secondary users. Also, the cognitive base station and the primary user base stations are all created in the network. So this indicates the network model. After that, the users all generates packets. That is, the primary or the secondary users generates packets to communicate. After that, the channel assigning is processed. In that, it assigns the frequency for each user. If the channel is present, means it access the channel. That is, if the channel is free for the primary user, means the secondary user automatically access the channel with the help of scheduling process. After the channel is assigned, the packet forwarding is performed. Finally, the performance is analyzed for the performance matrices like delay, throughput. Let's see the output demo of our process. First, open the terminal window, then type cd space code. So in that directory, we have the code for to be run. Our main code is ns space file name dot tcl. Now the nodes are created in the network and the coding is running. After the running is completed, the output is shown in the network animator window. To see that window, maximize this, and to run the simulation, click on the play button. Here, the base stations for the primary users and the cognitive base stations are created. These are all the primary users and these are all represent the secondary users in the network. Now the primary user normally generates packets and communicate with the base station. We can speed up the process here. The primary user is communicate now. If the channel is free for this user, means secondary user will automatically communicate using this channel. Now the secondary users are communicate with the help of the cognitive base station, and again if the primary user comes, means it going to the channel is only used by the primary user. After the Running is completed. Back to the terminal window to show the graph. So type xgraph delay.xg. This is the delay graph which is for the proposed system. So for each and every time we have the time delay for our transmitted packets. And to see the another graph, type xgraph thr.xg. This is the throughput graph for each and every simulation time and how many maximum packets are transferred. This is the packet count in represented in y-axis. So packet count is varied for each and every simulation time. So that's all. Demo is completed now. Thank you for watching this video.